Hi guys, welcome back our favorite video channel SGVS. This is B Ramesh. Now let us discuss JEE Mains chapter wise solutions. Now here the one of the topic is application of derivatives. Now let us discuss in this topic one of the subtopic is maximum and minimum. From this topic there are came 6 questions in last January 2020 session. Now we discuss the solutions of the sums. Here the first sum is let f and g be two differentiable functions on real number set R such that f circle g is an identity function. If for some the constants a b belongs to real number set, g dash of a equals to 5 and g of a equals to b, then to find the value of f dash b. Here given f and g are two differentiable functions. Now we go to the solution. Given f and g are two differentiable functions and also given the composite function f circle g is an identity function and f circle g is an identity function. Here this means the definition of identity function is f circle g of x equals to x for every x belongs to R. Now here we write f of g of x equals to x. Now we differentiate with respect to x because of these are two differentiable functions already given in the problem. Now differentiate with respect to x on both sides. We have here f of g of x, that means f dash of g of x, and we write the derivative of g of x, that is g dash x equals to, in right side the derivative of x equals to 1. Here we observe that f dash of g of x into g dash x equals to 1. Now from this one f dash of g of a into g dash of a at x equal to a is also 1 at x equals to a. Now already given g of a and g dash of a. So g of a value is b. Now substitute in this f dash of g of a equals to b. So f dash of b into g dash a, that value is 5 equals to 1. Now which implies f dash b equals to 1 by 5. So here our value is f dash of b, that is 1 by 5, which is in the option fourth one. This is the solution for this question. Now the second one is let fx be a polynomial of degree 3 such that f of minus 1 equals to 10 and f of 1 equals to minus 6, and fx has critical point at x equal to minus 1 and f dash x has critical point at x equal to 1. Now to find the value of the local minima of the function f at which value of x. Now which is integer type question. Here given fx be a polynomial of degree 3. Let fx equals to ax cube plus bx square plus cx plus d. Already given f of minus 1 equals to 10 and f of 1 equals to minus 6, and also given fx and f dash x has two critical points at x equals to minus 1 and x equal to 1. Here critical point means the derivative of that function equals to 0 at that point. Now that point is called critical point. Now here given fx has critical point minus 1 and f dash x has also one of the critical point at x equals to 1. Now here first of all derivative of f of x, that is f dash x equals to 3ax square plus 2bx plus c. Again differentiation to this function, that is f double dash x equals to 6ax plus 2b. Here given f dash x has critical point at x equal to 1. That means second derivative of that function at the point 1 equals to 0. Since f double dash of 1 equals to 0. Now using this one, that is 6a into 1 plus 2b equals to 0. Here 2b equals to minus 6a. That means b equals to minus 3a. Similarly, using f of x has critical point at x equal to minus 1. That means derivative of f of minus 1 equal to 0. F dash of minus 1 equals to 0. Now which implies that is 3a into minus 1 whole square plus 2b into minus 1 plus c equals to 0. That means this is plus 3a, this is minus 2b plus c equals to 0. From this c equals to minus 3a plus 2 into b value is minus 3a. So the total value is minus 9a. Similarly, using f of minus 1 equals to 10 and f of 1 equal to minus 6 and f of minus 1 equals to 10. That means substitute the value of x in f of x. In this is minus a plus b minus c plus d, that equals to 10. Now from this the value of d equals to 10 plus a minus b plus c. Here substitute the value of b and c in terms of a, that is plus b equals minus 3a. Now minus b equals to plus 3a and c equals to minus 9a. Now that equals to 10 4a minus 9a, that is minus 5a. So this is d. Therefore d equals to 10 minus 5a. Similarly, using f of 1 equals minus 6. F of 1 equals to minus 6. Now which implies a plus b plus c plus d, that equals to minus 6. Now from this d equals to minus 6 minus a minus b minus c. Now here minus 6 minus a minus b means plus 3a, minus c means plus 9a. So this is 9 plus 3, 12a minus a, that is minus 11a. Minus 6 plus 11a. So that is d. Now here equating the values of d. Therefore 10 minus 5a equals to minus 6 plus 11a. From this 11 plus 5, that is 16a equals to 16, which implies a equals to 1. Here we get a equals to 1. Now using d equals 10 minus 5a. Therefore d equals to 10 minus 5a, that equals 10 minus 5. This is 5. d equals to 5. Similarly, c equals to minus 9a, minus 9 into minus plus 1, that is minus 9. b equals to minus 3a, minus 3 into plus 1, that is minus 3. So already we get the values of a, b, c and d. Now substitute the values in f of x. Therefore f of x equals to, here ax cube. Ax cube means x cube, 1 into x cube, x cube. Bx square, b means minus 3, x square. Cx, c means minus 9x, d means plus 5. Here derivative of this one equals to f dash x equals to 3x square minus 6x minus 9. Now which equals to 0 because of f of x has critical point. Now here which implies factorizing this equation, that is divide with 3, x square minus 2x minus 3 equals to 0. Now here we write the product of x minus 1 into x plus 3 equals to 0. Now which implies here x equal to 1 or x equals to, so this is x equals to 3. Here x equal to minus 1 because of fx has critical point at x equal to minus 1. Here therefore the minimum value of that function f of x equals to 3. Therefore local minimum of f at x equals to 3. So this is the solution for this question. Now the third one is, let fx be a polynomial of degree 5 such that x equal plus or minus 1 are its critical points. If limit x tends to 0, 2 plus fx by x cube equals to 4, then which one of the following is not true in given 4 options? So in this problem given, limit x tends to 0, 2 plus fx by x cube equals to 4. Now we can simplify that. Limit x tends to 0, fx by x cube. Here we take the constant to right side, that is 4 minus 2 equals to 2. Now here we observe fx is a polynomial of degree 5. In this, the limit is the finite value. Now here we can take fx equals to sum a into x to the power of 5 plus b into x to the power of 4 plus c into x cube. Now the remaining values will be vanished because of here the limit of that function. In the denominator the value is x cube. Now divide with x cube to the function. So remaining terms compulsory 0. Now that value is 0. So here we take that function only ax power 5 plus bx power 4 plus cx cube. So the remaining values are zeros. So now substitute that function in this one, that is the limit x tends to 0. Here ax power 5 plus bx power 4 plus cx cube divided by x cube, that equals to 2. Now divide with this one, that is limit x tends to 0. In this ax square plus bx plus c, x cube by x cube will be cancelled, that value is equal to 2. Now substituting the limit value in this one, that is 0 plus c equals to 2, which implies c equals to 2. Now here f of x equal to x power 5 plus bx power 4 plus cx cube. Now we substitute the value of c in this one, then fx equals to a into x power 5 plus b into x power 4 plus 2x cube. Now we derivative the function f of x with respect to x, that is f dash x. So 5a into x power 4 plus 4b into x cube plus 6x square. Now here given x equal plus or minus 1 are two critical points of f. So that means derivative of that function at x equal to 1 and minus 1 equals to 0. So since f dash 1 equals to 0, which implies, now substitute the value of x equals to 1 in this f dash x, that is 5a plus 4b plus 6 equals to 0. And f dash minus 1 also equals to 0. Now which implies in this 5a minus 4b plus 6 equals to 0. Now from these two equations, which implies in this 4b cancel, 10a equals to minus 12. That implies a equals to minus 12 by 10. So that means minus 6 by 5. And b equals to 0. Now subtracting these two. 5a cancel, 6 cancel, 4b plus 4b. 8b equals to 0. That is b equals to 0. Now here the function f of x equals to, a value is minus 6 by 5. So minus 6 by 5 x power 5. B value is 0 and c value is 2. So 2x cube. So this is f of x. Now to find f dash x. F dash x equals to minus 6 by 5 into 5x power 4 plus 6x square. In this 5 cancel, that value equals to minus 6x power 4 plus 6x square. Now we take common minus 6x square. In this, that value is x square minus 1. Here we can write minus 6x square into x plus 1 into x minus 1. Here f dash x at x equals to 1, that function has critical value. Therefore f dash 1 equals to 0. Now which implies in this minus 6x square into x plus 1 into x minus 1 equals to 0. Now in this f of 1, from this x equals to 0 plus or minus 1. So in this f of 1 equals to minus 6 by 5 into 1 power 5 plus 2 into 1 cube. So minus 6 by 5 plus 2. So 5 to the 10 minus 6, that is 4 by 5, which is positive. And f of minus 1, that is minus 6 by 5 into minus 1 power 5 plus 2 into minus 1 4 cube. In this minus 6 by 5 into minus 1, that is plus 6 by 5, this is minus 2. So minus 10 plus 6, so minus 4 by 5, which is less than 0. We observe f of 1 is greater than 0 and f of minus 1 is less than 0. That means at x equal to 1, the point of maximum, which is maximum value at f, at x equal to 1. At x equal to minus 1, which is less than 0. That means the point of minimum. So therefore x equals to 1 is a point of maximum because of f1 is greater than 0 and x equal to minus 1 is a point of minimum. Now we observe the second option is right option. Similarly, by verification, first option. By verification, first one is f1 minus 4 into f of minus 1. In this f1 already found, that is 4 by 5 minus 4 into f of minus 1, that value is minus 4 by 5. Now in this 4 by 5 plus 16 by 5, so that is 20 by 5, which equals to 4. Now f1 minus 4 into f of minus 1, that value is already 4. Already we get the value is 4. So first option is also the right answer. Similarly, third one, f is an odd function. Now we substitute x by minus x. So that is f of minus x. F of minus x means minus 6 by 5 minus x whole power 5 plus 2 into minus x whole cube. In this we take common minus, that is 6 by 5 x power minus 6 by 5 x power 5 plus 2x cube. So here we write minus of f of x. Now we observe f of minus x equals to minus fx. That means f is an odd function. F is an odd function. So third one is also right option. In fourth option we observe x equal to 1 is point of minimum and x equal to minus 1 is point of maximum. Already found x equal to 1 is a point of maximum and x equal to minus 1 is point of minimum. Now from four options, first three options are right answers and fourth option is not true. So our correct option is fourth one, which is the not true. Remaining three options are true. This is the solution for this question. Therefore fourth option is not true. One is let fx equal to x into cos inverse of sine of minus mod x. Now x can be taken in open interval minus pi by 2 plus pi by 2. Then which of the following is true? In given four options, which of the following is true? Now we go to the solution. Fx equals to x into cos inverse of sine of minus mod x. Now it can be simplified that here x belongs to open interval minus pi by 2 plus pi by 2. Here we can write x into, in this cos inverse of sine of minus theta can be written as minus sine theta. So minus sine of mod x. Also we write cos inverse of minus x, that can be written as pi minus cos inverse of sine mod x. That equals to, here we observe that x into pi minus, here it can be written as, already we know one result, inverse trigonometry, cos inverse x plus sin inverse x equals to pi by 2. Now using that result, pi by 2 minus of sin inverse of sin mod x. Here we observe sin inverse sin cancel. Now we can simplify that x into pi minus of pi by 2, that is pi by 2 plus mod x. Sin inverse sin cancel mod x. Now that equals to, in this, x into pi by 2, we can take mod x equal to x. Here x is always greater than or equal to 0. This is one case. Similarly, x into pi by 2 minus x, we can take x is less than 0. X is less than 0, that value is x into pi by 2 minus x is greater than or equal to 0, x into pi by 2 plus x. Now that equals to, multiply with x, pi by 2 x plus x square, for x is greater than or equal to 0, pi by 2x minus x square, x is less than 0, that is f of x. Now here we differentiate with respect to x, that is f dash x equals to, here pi by 2x means pi by 2 plus 2x, for x is greater than or equal to 0, x square derivative 2x. In this, pi by 2 minus 2x, x is less than 0. Now here we observe, we take x is positive, then f dash x is always positive. F dash x is always positive. Now in this, f of x, f dash is increasing in the interval. X can be taken as positive values, that means 0 to pi by 2, open interval. Similarly, and we take x is negative value, x can be taken negative. Now that value is small values, so that is f dash is decreasing in minus pi by 2 0, minus pi by 2 0. Now we divide the interval minus pi by 2 plus pi by 2, that can be divided to two subintervals. In 0 to pi by 2, f dash x is increasing, in minus pi by 2 0, open interval, f dash is decreasing. Now which is in the option? F dash is increasing 0 to pi by 2 and f dash is decreasing in minus pi by 2 0. Second option is the correct option. So this is the true for all given options. This is the solution. Now the fifth one is, let a function f is mapping from closed interval 0 5 to real number set R be a function. F of 1 equals to 3 and capital F be defined as capital F of x equals to integral 1 to x t square into g of t dt, where g of t equals to integral 1 to t f of u du. Then for the function capital F, the point x equals to 1. Here the function capital F at the point x equal to 1 is point of inflection or point of local maxima or point of local minima, or x equal to 1 is not a critical point to the function capital F. So in this problem, given g of, we take first of all g of t, given g of t equals to integral 1 to t f of u du. First we find derivative of that function. Now using Leibniz formula, we know that Leibniz formula is d by dx of f of x equals to integral psi x to phi x f of x dx equals to f of phi x into phi dash x minus f of psi x into psi dash x. This is Leibniz formula. Using this formula to find derivative of that function g of t, g dash of t, it equals to, this is t. Now here f of phi of x, that means f of t into derivative of t, that is 1 minus f of psi of x. So f of 1 into derivative of 1, that is 0. Now here, which is clearly equals to f of t. Now which implies in this g dash of 1 equals to f1. G dash of 1 equals to f1. Now which is equation 1. Now in second equation, f of x, we take capital F of x equals to integral 1 to x t square into g of t dt. Here also using Leibniz formula to find derivative of that function. F dash x equals to, first we write f of ix, that means x square into g of x into derivative of that function, that is 1, minus 1 square into g of 1 into derivative of 1, that is 0. So now we say simplify that f dash x equals to x square into g of x, that value is 0. Now this is equation 2. Now again differentiate to f dash x, that is f double dash x. Here this is uv form, uv dash plus u dash v. So in this, x square into g dash of x plus 2x into g of x. Now at x equals to 1, f double dash 1 equals to 1 square into g dash of 1 plus 2 into 1 into g of 1. Here we observe g of t equals integral 1 to 3 fu du. So in this, at x equals to t equals to or x equals to 1, in this integral limits are same 1 to 1. Between same limits, the integral value is 0. So g of 1 equals to integral 1 to 1 f of u du. That value is always equals to 0. Now in this is g dash of 1 plus 2 into g of 1 value is 0. So f double dash 1 is always equals to g dash of 1. Now we observe g dash of 1 equals to f of 1. Now substituting the value in this one, therefore f double dash 1 equals to small f of 1. Already given the value of f of 1, that is 3. So which equals to 3. Now here we observe at x equal to 1, second derivative is always positive. That means f of x has local minimum at x equals to 1, that is 3. So which is in the option 3. Third option is the right answer.